Gogó mesmo. Então a gente vai ter que falar alto para vocês poderem ouvir. Mas podem me avisar se não estiverem ouvindo, tá certo? All right. So we have a. I'm going to speak in English. Is that okay? Or do you want me to translate? Okay. So we have a speaker today with us, and I think you really like his presentation. I'm really excited to learn with him. And to begin, I wanted just to bring the hello from our chancellor on research and postgraduate and graduate work here at the University of Pernambuco, Professor Dr. Carmelo Bastos Filho. He asked me to say hello to everyone. He really wanted to be here representing our president, Doutora Socorro, but he had several meetings and he has to go to Rio de Janeiro for a meeting with FIEP. Tá muito baixo ainda? Let's try. Speak louder. Okay. So, Professor Carmelo, it has been an honor to work with him in the past 4 years. I worked with him 2 years in the Secretary of Science and Technology, Innovation of Pernambuco, and he was one of the responsible for creating a program called Forma-I, where we had the opportunity to capacitate 20,000 people in Pernambuco on STEM, in the STEM area. And we had more than 300 or 400 companies that were attended by the program, where the students from high school and university level went to the different companies, and even we went to prefeituras. I don't even say how to say prefeitura, but in the city councils, to help them solve problems using technology. So it was revolutionary, the program he created, and I had the opportunity to work with him. And he's from the computer area also. He's electrical engineer in the computer area. And this week we also celebrate the Day of the Women in Science. Here and our coordinator for graduate and research at Poly, which is the School of Engineering of UPE. It's going to be our director for one day tomorrow, actually. So I'm going to invite her to do the opening of our talk today.
Very quickly. Good. Okay. I am Maria de Lourdes Alcoforado. I am the coordinator, sector coordinator here in Poly of postgraduate. And it's an honor to have Dr. Hassan Morse with us today, especially in such a significant week as we celebrate the 112th anniversary of the Polytechnic School of Pernambuco, where research events are in full swing. On March 50th, we had the Poly Showcase Awards in various categories. And tomorrow, we look forward to the first women in STEAM seminar at our school. We are the State Public University of Pernambuco, offering courses in electrical engineering, mechanical engineering, civil engineering, and materials physics. We are in computer engineering. And we are here in the presence of Professor Dr. Márcia Macedo, the Innovation and Sustainability Manager at University of Pernambuco, who is currently working on Smart City projects. And to support us as the chair of this session, we are fortunate to have the distinguished Professor Dr. Emilia Rabani, the current research manager of postgraduate street science at University of Pernambuco. So thank you very much.
Thank you, Lourdinha, my dear. It's a pleasure to, if you would like to. It's easier to watch from the other side. I'm also going, after I present Dr. Hassan Marcy today, I'm going to go there and watch your presentation from there. No, you're not alone. We're all here for you. So Dr. Hassan Morsi is a seasoned technology executive with 25 years of experience. He currently serves as the Chief Information and Technology Officer, CITO, for MyRated, an international fintech. financial technology company, delivering cutting-edge solutions for digital wallet management. Hazem has held various executive positions at several companies. Most notably, he was the CIO of Avaya Incorporation and the head of applications delivery at Version Retail and Version Business. He earned his Bachelor of Science degree in Computer Science from the American University in Cairo and a Bachelor of Engineering degree from White University. He then received his Master of Science and Computer Science degree from Texas A&M University, focusing on distributed system and real-time scheduling algorithms. Subsequently, he obtained his PhD in computer science, specializing in optimization theory in data and process routing in cloud computing from Southern Methodist University. Hazem's research interests encompass cloud computing, wireless ad hoc computing, autonomous computing, data management, optimization algorithms, and machine learning. His scholarly work has been featured in major academic journals, and he has presented at prestigious industry conferences such as IEEE, ACM, Oracle World, Salesforce, Dreamforce, and SAP Sapphire. So, Dr. Hassem Morsi, it's a pleasure to have you here and to learn with you.
Good morning, everybody. So I cannot translate anything in Portuguese. I can do it in Arabic if you're interested. So I'll try to go slow. And please, I like interactive discussions. So don't feel bad if you want to interrupt me. If you want to say I didn't get it, if you want me to say repeat, more than happy to do that. Okay. How much time do I have? I don't want you to fall asleep, so I'll try to make it. If I see people starting to doze off, I'll know that this is time to stop. So hello everybody. I am really pleased. I like to stand up, so if you don't mind. So first thing, let me dismiss a rumor that I was told that you think I'm a famous soccer player or a football player. So just to clarify that rumor, I did play competitive and I was offered to play professional. But this was 30 years ago and 50 pounds lighter. I was skinnier than that. But yes, I did play in Egypt. I played for a club. Again, that's my claim of fame. I'm not famous but Mo Salah, the Liverpool player. So I played in the same academy that he played in. That's my claim of fame. But I did play, and then I played in college, and I still played to some extent, but I have a bad knee for the last 4 years. That's why I have a nice belly now. But anyway, just want to dismiss that rumor. I still will sign autograph if you want. I'll don't mind. But by the way, I'm glad to be in Brazil because since I was a kid, Brazil is like the team to cheer for. I keep telling this to my kids. My best team that I ever watched play was the Brazil 1982, Zico, Socrates, Eder, Falcao, Junior. I'll go on and on. So, and this was the team that inspired me to play. I was 10 years old when I watched that World Cup, and I cried like crazy after the Italy game. And that's why I hate Italy. I like Brazil. I hate Italy. But anyway, just wanted to start with that. A little bit, I know Professor Emilia gave you a little bit about me, but let me tell you a little bit personal about me. I grew up being a football player, and my dream was to be a football player. And then something happened because if you in Egypt, if you sign a contract, you're not going to go to college. You're going to become a professional. So I made a decision to quit and pursue academia. That was my first switch in my career. The second switch is that my father is a professor in psychology. So I grew up in academia, and I said, okay. And I grew up, I'll be a professor like my dad. So the second dream, so football now is aside, the second dream was to be a professor and teach in college. And then finished my 2 bachelor's, masters, and midway in my PhD, I kind of got tired and bored of doing a lot of theory. I mean, in academia, you don't get to see applying what you do to the effect of being, I mean, for a large scale. You can do it in an experiment, you can do it for prototyping, but to see it in a large scale was something I was missing. And I didn't know what I was missing, and I was kind of getting tired. So I did an internship with a company called Verizon. It is a big telecom company in the US. And I started having another passion, which is I love to solve problems and see how it works. And during that path, also, I was planning to be a developer my whole career, just develop code and do coding. And then I found another passion of mine, which is managing and people skills. So I like to mentor, coach, and lead. And I found that passion. I had a lot of good people on the way that mentored me or coached me and made me understand certain values. So I pivoted again into management. So in professional career, when you go there, you'll find you'll have 2 tracks to focus on one of the 2. You either stay technology specialist or more heavy involved in technical development. And these are, we call individual contributors. They don't manage people, they manage technology. So these are the people you hear about being fellows or senior fellows and so on. So they are more ending up in the product side of the research and development. The second track is being in management, which is going to managing people, executives, directors, or the executive directors, VPs, and so on. And they're different. If you do the management track, you're gonna move, as you go up, you're gonna move away more and more from the hands-on technology experience that you have. So that's what I ended up doing. But to regain my touch into technology, I went back for my PhD, and I finished it in 2015 or 2015. And that was, I found a balance between my love for being a techie and a researcher and working in management and being involved in the professional career. I'm giving you this intro just to, because I see a lot of young faces and I don't know who's undergrad, who's grad, but I wanted to give you that perspective to understand that what you're thinking about for your career right now is going to change. And you have to, the best advice I was given when I was young was that you have to be flexible. You have to basically adjust to the situation, to what's going on. And to do it right, you have to teach yourself how to pivot in certain moments. You will get points in your career where you will have to make a decision. You don't know what's going to happen in the future, but you go with your passion, you go with what you're really good at, and you always keep reinvent yourself. So one thing that you have to understand, especially work in technology, when you graduate, you're not going to stop learning. And if you do that, you're gonna have a hard time finding or growing in your career. You're going to have to always find a way to reinvent yourself. Learn new things. I mean, a lot of the things that I'm going to talk about today, I have to acquire as I went through. I have to learn. I have to teach myself. I have to work with others to get to that point. It's important to keep that in mind because all we're doing here, your professors and somebody like me who's coming in, is put a seed in your head. You're not all going to react to my presentation the same way or to a lecture the same way. Some of you are going to get it in a different context. Some of you are going to be excited about it. Some of you say, yep, that's boring. That's not my stuff. That's not for me, which is okay. But try to get the idea of, I'm going to try to present to you a problem that I try to solve, and I have an idea of how to solve it, okay? The method that I'm going to explain, you're going to apply to anything you're doing, whether it's professional, academia, or whatever. It's the sequence of any problem statement you're going to face in your career. And then you take that and see how you're going to grow with it. Okay? I had given a talk 2 days ago in the Federale University, and it was different. It was about IT evolution, the IT market, job market evolution over the last 30 years, and what's the trends for the future. So that presentation was more my professional side, my executive leader side. This presentation is more my academia side. So, but I'll try to bring in some of these points because I think you're going to benefit from that. All right? So, good with that long introduction. How many undergrads and how many grads here? Just to understand the. So, this is undergrad. Okay. Grad? Okay. 4? Okay. All right. So, let me get going. It's not moving, or is it from your end? Okay, let's work. It worked now. It moved. This it doesn't change here, or there's latency. Okay, you know what? I'll watch it from here. But you cannot see it. You know, it changed here, but it didn't change here. It's not changing. Let me try something. Should I stop sharing?
Do you have USB? No. Do USB, USB-C. É o contrário. Esse aqui, bota assim, bota isso aqui. Adaptador USB-C.
No, no, no. That's okay. It's okay. This they cannot see. It doesn't change anything. That's the problem. Okay.
Can you at least get
Listen. Can everybody see? It's going to be small. The technical problem. See, that's a problem we need to solve. I didn't. You know. We did the full screen. We tried the full screen. It didn't change. That's right. Okay. If it changes, okay. Yeah, it's fine. I'll do it then. I'm okay. That's good. Okay, I'll do it. I can do it. Correct. Okay. So, you guys figured out something I didn't know. Okay. So let's get started. So. Okay, so today I'll give a brief introduction. So just to explain this topic a little bit. So I was asked to talk about smart cities and application smart cities. My work, my research is really in optimization algorithms in data collection. So optimization is more of an operations design kind of a problem. And I took that into the how to optimize data collection. The concept that I built in my PhD, I carried into different research areas. One of them is what for smart cities or environments that has equipment, there is a way to handle disaster situation. Disaster means earthquakes. If there is like a tsunami, any of these natural disasters that causes a crisis into a situation. Okay. And I'll explain in a minute the thought behind this, because a concept like this would probably 10, 15 years ago was something that's hard to consider as a practical area. But now it is something that I think it has a very widespread utilization of it. Thank you. So we'll talk about introduction, the motivation and impact, the smart data for crisis management, and I'll explain what smart data means, data routing versus network deployment, and then we go into what the problem statement that I solved. So it's a little bit of a long introduction, but I wanted to do that for this talk. Usually I would do a quick introduction and jump into it, but given that we have a mix of undergrads and grads, I decided to make the intro a little bit longer just to explain the concept and the reason behind it. It's very important to, especially when you're doing research or doing any solution, is really to have a perspective of what you're trying to solve and be flexible in your definition of the problem, because I think some of you took algorithms, computer algorithms. So you've heard of something called NP hard or NP complete. So these are problems that you don't have one right exact solution. It's impossible to solve. In the current computational power we have, it is hard to solve. So these problems, they do something what they call heuristic, which is find the closest solution to solve that problem. So it's not exact solution, but it's the closest to the solution. So this is a model of that concept, okay? And please, if I am going too fast, if it's not making sense, stop. I'll explain again. I have no problem. We'll talk about autonomous data collection, which is the main work that I've done, or at least I'm working on. And then simulation case studies, and then the potential future work and the challenge in that area. So the first thing, if I ask any of you, what is the definition of a smart city? Can anybody give me just a thought? What is a smart city? So would smart city be a city that has connected devices? That's a smart city? Okay, so what's a smart city? self-sustain itself. Okay. Anything else? Anybody else? Data. That's actually a great point. Any other thoughts? So you can see we cannot agree on one definition of what a smart city is. To you, if I tell you this is a smart guy, it means that he has an answer to something I asked that I didn't know about. So in a smart city, there are many ways. I mean, connected devices in traffic lights would be considered a smart traffic control, for example. Autonomous cars that self-drive itself, Tesla and so on. I was telling somebody a couple of days ago that the Tesla, the autonomous driving, this concept was not invented recently. It's actually, I read a paper in 2007 that BMW was testing at the time, was testing a full connected self-driving car from home to your office. Basically, it communicates with the traffic lights on the way to find what's the optimal time to leave the house, so you don't spend too much time in traffic lights. So it communicates, calculates the time. So it tells you leave at this time, and you will have the fastest route. And this was 2007. Okay. So for something like this to work, for example, you need to have smart traffic lights. Okay. You need to have infrastructure of roads. Another point, that the data. If I have connected devices, but I'm not understanding the data, it's pointless. You're not going to be able to tell what to do. So I want you to understand this, because when I started working on these IoT, and now we have what's called the Internet of Everything. So there is the Internet of Things and the Internet of Everything. And the reason why this definition or this label is coming to fruition and becoming a standard is that you, as a person walking around, you are a connected device, because you're walking with your cell phone. Your cell phone knows everything about you. Your cell phone is you. It's your behavior. It's your health information. It's your people you connect to. And of course, now we have our smart watches, and God knows what they have. I mean, I think I'm not sure if you have read about Elon Musk most recent experiment, which is planting a chip in a guy that has dementia, early stage of dementia. They implanted a chip, and the idea is that this chip will be able to help restore memories, slow down the neurological damage on the brain. So look, these things, you're going to become one of the nodes in that smart city. And I claim that you will be the most critical piece in that connected piece that makes something smart, because you can make your house smart by just you and your family in the house. So keep this in mind. And I'm just showing you something here that the trend is showing that we are not slowing down in terms of how we adopt mobile devices, how we adopt smartphones, and now with the metaverse and the new connected goggles and the Apple Vision, there is a new dimension, which is what we call 3D internet, is getting into our way now. And probably virtual learning and virtual work is not going to be the Zoom or the video conference. It's going to be you sitting in a room and you're working with your colleagues or with your students virtually. We actually did an experiment or a prototype of this in Avaya in my last couple of years, where we prototyped. Avaya does call centers solutions, which is basically the solution used in the call center. So we did prototype the concept of the call center. Basically, rather than them being in a physical place, the agents are sitting virtually at home, and virtually connected in a call center and communicating with the customer. Then there is also the concept of the customer talking to you as a consumer, as an agent, as a customer care, virtually in the same virtual room. So you will have that live interaction. If we have time, I'll show you a prototype of that. So the idea here is that there is an exponential growth of smart devices and IoT. And if you look at the statistics, we're almost going in a rate of twice the growth number. So almost 33.7 million shipments. We have 6.6 billion devices, and every year we have almost a double of that. So this is not going to slow down. The IoT connected devices is expected to reach 75 billion by 2025. So there will be a huge wealth of data, a huge wealth of connectivity that will make any environment what we're calling that smart environment, or could potentially be the smart environment. Okay, so keep that in mind. The second is the localized data. So the biggest challenge that you're going to see moving forward is that how we manage and manipulate and utilize the data to make a decision. That decision could be to sell you the latest Nike shoes. That decision could be to tell you about the fastest route to get somewhere, or that decision could be, I'm saving your life. So in the US, I don't know if you have it here too, but Apple, for example, you sign up for your phone, you have to consent to sharing your health information to when you call 911, or if the phone or the watch detects that you're in an accident, it will automatically tell the ER your blood type, because if you need blood transfusion, it tells your blood type, you have allergy, if you have any certain health concerns, health history. So these things could help save people's life. So that, again, that concept is, I mean, the Apple Ultra has the capability of, if it detects you're in an accident, it will automatically call 911 on your behalf. It's not going to even wait for you. Cars are doing that right now. So the data is going to be huge. And one of the big challenges, how to mine that data. You know data mining? So data mining quickly is how you basically insert key navigation of the data, looking for key values, keywords, key logic that will help you make a decision. Okay? So the biggest challenge in this area is that this huge wealth of data, these terabytes of data, how are we going to navigate fast and make decision fast? With AI now and quantum computing. So again, when I said 10, 15 years ago, a lot of these ideas were more of research because we did not have the computational power to do fast navigation of these huge terabytes of data. Now, things are moving really exponentially fast. I mean, if you're interested, I would strongly suggest you research quantum computing. This is the new wave of algorithm or execution or processing power that you will, it will be a new dominant space that's coming off this whole AI evolution. Safety and commercial benefits. So we talked phones are going fast. Data is becoming available. And now how we make use of this data. There is real-time monitoring and what I just mentioned about the healthcare issues or health situation, location-based services. I think you all seen it. One day I was walking to a Nike store. When I was inside the store, I get a message in my phone, a promotion, 10% for Nike if you buy for $100. So this location service is now becoming a fact of life. They know your behavior, your patterns. I know my kids have spent whatever because I keep getting messages about, would you be interested in buying this toy or this whatever? So I'm not interested in the toy. Then I realized that one of my kids just kept researching in Amazon and different places for something specific. So that's how they're now tracking the behavior. And also you have, they're estimating that from a commercial perspective, 157 billion of additional revenue will come out of this kind of additional data, smart data that you collect from your devices or your behavior. And then the personalized experience. So these are just kind of charts that will help you kind of see what I was just talking about. So let's talk a little bit about, now I'm going to go into the motivation. I will give you three perspectives. The first perspective, the smart city and the evolution of the smart city. So we're talking about what's a smart city, or what does a smart city give us? Better resource management. So we talked about energy consumption. If you have water, using water, electricity, power, all of this, these are resource management. Improved quality of life, the ease of being able to Google open the lights, Google turn on TV, Google change the channel. These are becoming conveniences. and it's convenience for you and me. But imagine somebody with a disease, with MS, multiple sclerosis, who cannot move. So these technology, yes, to you and me is luxury, but for others, these are becoming now a life enabler. Somebody who's dealing with blindness, for example, cannot move, navigate space. So yes, it is a quality of life, but also in some cases, it is an enabler of life. Sustainability, again, smart city and recycling, and the whole ESG. Have you heard of the ESG concept? Environment, social, and governance. So this is another new area in technology that's evolving right now that needs new engineers, new mindsets. It's basically about how to make your company using technology environment conscious, socially conscious, and provide the governance to manage or to control that. And companies now are getting ratings, 5 stars, 3 stars, 2 stars. So this is now is a new trend, but it will become a main trend. So this is one of the things I told the students a couple of days ago, that it's an interesting area. It's still new, and it doesn't need just technology. It needs lawyers. It needs technical skills. It needs people who has the business mindset. So it is something that you should look into about how to adopt this thing into your maybe considerable research, future research. And then economic development. Like I said, having this connected data helps the government sell you, or in some cases, in bad cases, I don't know if you know, but for example, in some countries, I'm going to go into names, but in some countries, they actually track your facial recognition. They know where you've been. And the claim is, we want to make sure you're safe, or if when the pandemic, they use the pandemic as the excuse because they wanted to make sure people are quarantined and they're not out, but it became a privacy invasion issue. And in some countries, they actually use that to prosecute people, to go find who is talking to, for example, an opposition, or who is. So sometimes this kind of smart city becomes a challenge if it's in the wrong hand. But the idea is that there is these 4 parameters are drivers or kind of enablers in the smart city environment. So this is just a quick snapshot of what a smart city in the main areas that we just talked about. I'll give you examples, and then forgot to give you example, and then there is some example of countries that does that. So I just covered it, but mainly Singapore, Toronto, they are known for smart governance, so the e-governance. Buildings, the building IM or building infrastructure model, these are smart buildings that have what you call the infrastructure. So the building is connected, all the houses are connected, so it's very streamlined behavior, and you find this in Dubai and Los Angeles. Traffic management, Berlin, Atlanta, the economic aspect, the e-business, e-commerce, and these are just examples of cities, not all of them, there are just samples. And the public safety and security in New York City and Tokyo, mainly from police, drones, surveillance, and so on. So one area that I wanted to, and these are just percentages of what are the hot or the more dominant smart concepts in smart cities. So what we just talked about, so public transportation, smart traffic, e-waste, and so on. And these are the percentage distribution between them. One thing I want you to, So if you look at this and the slides before, the main thing has been always about everything operating normally. We have an infrastructure, we have the connectivity. It's more about how to use the data to operate in a normal environment. And underline the word normal. Normal means connectivity is fine, towers are up, there is no major issues. The concept smart city has not evolved into dealing with disasters. So when a disaster happens, you cannot assume the connectivity that you have right now when everything is fine is going to be the same when a crisis happens, because you don't know if it's an earthquake, which towers went down, which buildings, which data centers shut down. So that is a problem that's now becoming, okay, so how do we work without an infrastructure? How do we have the autonomous management model to guide us through a crisis? Okay, I'll give you here some examples. 2004, the famous tsunami in Asia, in South Asia, it's almost killed 230,000 people and billions of dollars of damage. 2010 Haiti earthquake, 160,000 people. And earthquake in Nepal, 2015, 10,000 deaths. And most recently, last year in Morocco, 3,000 deaths. A lot of the death that happens, if you look at the statistics, they didn't die in the moment of impact. They got trapped, and to get to them took a long time, because basically you're searching in a rubble. So you're looking in a needle in a haystack, as they say. So you're guessing, I mean, think about it. 2 buildings collapsed. This building has 5 people survived but trapped. You can't see them, you cannot hear them, but they're trapped. This building had 100 people, but they're all dead. How would you know? How can you tell where to divert? I mean, in these situations, your resources, especially in countries like Haiti or even the tsunami issue, the infrastructure or the the responders will not be able to get to every place quickly. So you have to make a tough choice. How we educate ourselves or educate the responders to find the highest potential of survival. Okay, so that's one hint of the problem statement. Okay, so the current rescue techniques, basically they set up a crisis management center, manpower dependent. They have animals trained. I mean, you've seen dogs that go and sniff around. There is actually an example of they have cockroaches that they insert. They put a heat sensor on the cockroach and they put them in large volume, deploy them in that building because they can go through small areas and they can sense heat. So if somebody's alive, they sense their heat and the signal transmits back. But what if the roach goes too far from the signal? So they lose signal. So how do you get the data? So they're trying to figure out ways around that. The challenge, again, field coverage, as we just mentioned, risks of the rescuer's life, weather dependent, lack of information, and it's a centralized computing in the sense there is always a crisis center and everything has to rally to that center to make decisions for everybody. So if I am away, if I'm a responder, I'm a helper, and I'm away from that center, I don't have the information. I don't know what to do if I am already deployed for a mission and my mission failed, for example, I couldn't get to that person. Can I go to the next building and try to search? No, I have to go back all the way to the crisis management, report back. They tell me, nope, go to here, go there. So again, it's all centralized, which takes time, effort, and sometimes not feasible. And infrastructure dependent. Okay? So with that, and these are different types of natural disasters. So biological, I think we all dealt with the pandemic, at least in our lifetime. I've never thought I will live what's called a pandemic in my lifetime. But I'm sure you've had to deal with it either personally or you had somebody you know who had dealt with COVID. You have geophysical problems like earthquakes, volcanoes. You have the hydrological flood issues or mass movement. So some of these disasters are also man-made. So when there is, for example, a mudslide, like it happened, not where, but I read about it a few months ago. There was a mudslide that basically, no, it wasn't a mudslide. It was a fire spreading in a town, and people tried to move in masses, and that movement in mass was not coordinated, and it ended up causing some people to be trapped. So they couldn't get out on time. So you have also mass movement that can cause problems, meteorological problems like storms and tornadoes and so on, and climatological problems, which is really, again, droughts and wildfire and all this. So these are different types of disaster and crisis that it gives you categorization of what I call a natural disaster. Any questions so far? Okay, so So let's reset and have a fresh look at what we just talked about. So we said we have smart cities. We have you as the smart. I call you as a sensor. You're a human sensor, basically, because you with your phone or with a smart device, you are basically a human sensor. You transmit heat, you transmit ideas, you transmit data, you transmit information about you. So all of that are data that we have for you, okay? We have new thoughts or new horizons of computational power, the wireless sensor network. Or again, if you see in my presentation the word sensor or wireless sensor, it is basically a mobile device. Okay, so consider it. So it could be a real physical sensor or your device, because now these devices are sensors as well. Okay, mobile technology expansion. Then what the kind of risk or the kind of rescue model that we are thinking about? We want to find a way that allows us to navigate a crisis situation with minimal infrastructure and with a smart way to collect the data with high probability that you will get that data to the responder or the emergency responder, that they can find you or whoever is in that crisis fast enough. Okay? I'm going back, sorry. Okay, so the challenges it's just a recap. We have environments, we have disaster, uncontrolled environments, we have unpredictable behavior. So when a crisis happens, I mean, like I said, I cannot rely on towers. I cannot rely that data centers will give me data, or I can get the data through different paths. There are different disaster behaviors. So a flooded area is different than an earthquake area. A mudslide area is different than a pandemic area. So it's different things. So for example, if it's pandemic, there is minimal damage to your infrastructure. Infrastructure is still going to be up and running, but maybe there will not be manpower to manage or to operate. But in an earthquake, there is no infrastructure. Everything is done. Okay, and then the technology, we have mobile devices, we have data aggregation, we have maintaining wireless or limited computational power. So the other thing, when we are relaying the data, how do we compute the data, or where do we compute the data? I don't have access to a data center to send terabytes, and so I need to collect small data. I'll be selective about what data I collect, and then where to process them. And your devices, by the way, are very powerful now with these A chips, and I forgot what Samsung is using these days, but these are very computationally powerful devices. But again, they are dependent? They are battery dependent. So the heavier the computation, the device could die fast. And if your device dies in a situation like this, you're not going to find the cable and charge your phone. So I have to be careful with the data I'm collecting, the device I am using, and the power consumption on the device. Okay? Okay. So the smart data crisis management. So just a recap. We have sensors. So let's assume there is crisis. We have devices with act as sensor, mobile phones, IoTs, anything that's up that I can connect to is considered an active sensor. And it could be your thermostat in the building, it could be your phone, it could be your watch, it could be anything. Okay. How do we navigate the disaster area? So we have to have a data collection kind of setup for that. And then the critical role that we have for optimizing the data collection. So we said data selection, power, and location. And then after that, we have the how do we precisely identify where we could find people with the highest chance to rescue. Okay? Good so far? This is just a quick background about before I get into the algorithm to solve it, I want to give you just a perspective on what we're calling the traditional model of centralized data collection, which is what you see here on the left, versus the decentralized and the distributed. So Centralized, any data has to go to the center before the decision is made to do something. Decentralized, you don't have one central hub, you have many central hubs. So, for example, these 5 nodes, they are connected to this center. So they cannot talk to anybody else. They have to go to the center before they go to somebody else. Distributed, anybody can talk to anybody. You just need to find your fastest route. There is no designated node that says, I am the boss, everybody sends me data, okay? We are using a model that's kind of hybrid between these two, the decentralized and distributed, and you'll see it in a minute, okay? The advantage of the traditional model has always been focused on centralized. The problem with that is that, again, centralization means if I lose that central node, it's done. All of these connected nodes are out. The other thing, the cost to process this many data coming from all of them into one place is high. So if that centralized node is power dependent, you're probably going to consume its power fast. Okay? So with the decentralized and distributed, you have a little bit of resilience. You can configure how to navigate. If a node dies, you can still go around it. So you are allowing or giving yourself a chance of succeeding and surviving as long as you can. Okay? None of these has 100% chance of success. It's just the best chance of success. Remember the heuristic word that I used? So I'm trying to find the closest solution that would give me the best chance. Okay? So here is the problem statement. This is the disaster field. I have nodes deployed on site, or these nodes could be your phone, could be your Apple Watch or your smartwatch, could be your IoT device in the building, could be your fire alarm, could be anything. It's just a node that has a signal. That signal is limited, so that dotted circle is basically the range that this node can connect to. And the idea is that how can I collect this information from this field and relay it to some devices that are coming to help. So these devices are basically handheld devices that the first responder is holding in his hand, and he or she is going around the field trying to find survivors. These nodes are devices that reflect information in the crisis field. So while these are navigating around the field, we're trying to find how to relay data from these nodes to the responders to find the survivors. Okay? So how we can do that? So here is the concept that I want you to start with. So a little bit of background on this. So optimization theory that I mentioned at the beginning is the art of trying to find optimal solutions or optimal answers. There are many different algorithms in that front. Okay, one of the main algorithm I used, it's called auction theory. Auction, you know the auctions, right? You go to a place when you say, okay, I'll give an auction example. Who wants to buy this phone? Okay, it's an iPhone 15 Pro Max. Okay, so starting bid is what? 5,000. Okay, who wants to go more? 6? Okay, who's gonna go 100? Nobody? I want to sell it. I want to go back home. Come on, we need to make some money. So that's auction. Okay, so auction means I'm giving you something, a commodity, and you're giving me value for it, and I am deciding whether to accept your value or decline your value. Okay, there are 2 types of auction. There is the English auction, which is everybody keeps increasing. So they said 1,000, 5,000, until I get to a number. I say, you know what? Nobody's going to go higher than that. I'll take that number. Okay? There is the Dutch auction. It's the other way around. I will go in and say, okay, guys, 100,000. Who can meet that price? Nobody? Okay, how about 90,000? So I am going down. You see the difference? So English, you're going up, and until you get to the highest bid, and you stop. Dutch, you start with a value that you think you want, and if nobody is giving you that price, you start going down. Okay, 90,000, and so on. If anybody wants for 100,000, it's available, by the way. So with that concept, what we're doing is the following. This is the crisis field, okay? These are devices that are not fully connected. So, for example, this sensor or this device is connected. Red is talking to red, okay? This one cannot see anybody but this guy, okay? This one can see this guy and this guy, and so on. So green is one path, red is another path, okay? These SDMs, these are, I call them the sensor data managers. These are the devices that are hovering around the field, okay, to find information. I broke the field into zones. So this grid is equally size square. It could be one meter, 1 square meter, so 1 by 1. It could be 2 by 2. So it's really up to your assessment on the size of the field that has the disaster. Okay? It's important to define it in there is an optimal way to find the right size, because if this field is too big, you'll have way too many nodes in each square, which will mean each square will be heavy computational square. We don't want a heavy computational square, and we don't want too light computational square, because too heavy means this square will die quickly because everybody's going to be talking to everybody quickly. So they will consume the battery power on these devices fast. And you don't want one that has only 1 or 2 nodes, because the potential of them failing is high. Because if one of these 2 nodes dies, or one of the nodes die, the other node may not have any connection to other nodes. So there is an algorithm also that I've developed that defines what's the optimal size of these squares or these zones. When we have the zones, we create 2 main measures, 2 matrices. One I call the zone coverage matrix. Coverage means each zone covers how many, if a zone has a sensor that I can connect to, then that zone is active. It's covered. So it has a 1. If that zone is not able to communicate, then that zone has a 0. So empty zones by default will be 0. But also if a zone like this one has a node and that node is not connected, it will be also a 0. So basically, the algorithm maps the field into these zones and then assess quickly who I can talk to. And from that, starts giving 1s and 0s to the coverage. So now I have a map of the active zones and the dead zones, okay? And then we go into the zone density matrix. Density means each zone has how many active nodes inside the zone. So for example, this one has 2. So for this one, this line here is 2, 1, 2, 2. Okay, 2, 1, 2, 2. The first one is 1, 0, 0, 1, and so on. So you're creating now what we call active zones matrix and density matrix of the operating zone. So now I have 2 information as a responder. I know the areas that have live devices, the zones that have live devices, and now I know the probability of that zone staying with me to communicate for a longer period of time. So far, so good? No issues? Again, don't worry about the terms here. These slides are from 100 slides. Presentation has a lot of technical things, but I try to give you the perspective. So try to ignore, I put the terms here, but if you're interested, I'll be more than happy to share more details on that, okay? Okay, so now back to the auction now. So now we have collected data from zones, okay? We have coverage and we have density, okay? Now let's talk about how is this related to the auction theory, okay? Here is the concept. Let me just go back a couple of slides. Yeah. These devices, they are the sellers. So they are the ones that are selling their phones, in the sense that what these devices are looking for, or these responders are looking for, the highest reliable data source. So it will ask these zones, I want you to bid for me to connect, to talk to you. So the bidding war starts at how much each zone, how many connected nodes do you have? That's one commodity. What's the power level in your devices? So are they high power? So it means that their lifespan is long, so I can stay with you longer. And then 3, what is your historical reliability in communicating data to me? So history becomes a factor because autonomous, the word autonomous means I am self-learning from how you behave. So I self-correct myself. So for example, if a zone comes in at the beginning and says, I'm a very high reliable zone and I'm bidding on this and I will give you the best data. And then after 2 tries, the data accuracy or the data connectivity was low, then now I don't trust you. And now, even though you're coming with high marks in the first 2, your historical trends are not good. So I'm going to self-correct my auction to look for the next better bid. Okay? So basically the SDM here would say, okay, if I'm doing English auction, I'm going to say, I want zones to bid on my service to communicate with you to find what you have available from data to find survival. Okay? And it will do English by saying, who can give me highest data? So everybody bid high, everybody start bidding, and they start outbidding each other. Or they can say, the node says, I'm not going to accept anybody who's lower than this value, so which is a Dutch. I start with the high, and then I'll allow to go down little by little. Okay? So to implement this concept, we have 2 models, English and Dutch, and we have in each one 2 options, mutual inclusion or mutual exclusion. And mutual inclusion in the sense is the zone can bid on different bids at the same time. So zone 1 can bid on this request and this request at the same time. Mutual exclusion, I only can bid on one bid at a time. So I'm not allowed to bid many times. If I'm already involved in one bid, I cannot go for the other one. Okay? And the same thing with the Dutch auction. Try to go faster. So we talked about that. I think I explained it, but this is kind of the English and the Dutch, ascending, descending, and then the commodities here. Oh, I knew I was going to do that. Yeah, it's back up. Yeah, sorry about that. See, disaster recovery. So the commodities, just remember that the commodities here are, I'm gonna slide so I don't, field coverage, degree of connectivity. So I forgot to mention this. Each node has, or each zone has a degree of connectivity. So the more is, for example, this node can talk to this only, so 2. Trying to find one that has 3. Yeah, this one can talk to 1, 2, and 3. Yeah, couldn't think about this. So this one is a 3, degree of connectivity is 3. This one degree of connectivity is 2. This one degree of connectivity is 2. This one is 2. This one is 0. So the higher degree of connectivity means I'm going to get more data because you have friends. You're coming to me, you're bidding with your friends. You're not bidding alone, or you're bidding only with one friend. So this again increases my chance of finding more survivors. Okay? Okay, here is an example of how the algorithm works. It's a sketch, but this is exactly how the algorithm operates. I set a parameter at the beginning. So, and this is part of the whole simulation. So I had to do a lot of different simulation, but the idea is I set a parameter on the participating zones in a bid. So how many zones can join in to create a bid? So in this case, I have 6 zones. Each bid has 6 participating zones. How do we come up with this number? You do some experimentation, trial and error, but there are also algorithms that you can optimize based on degree of connectivity, field coverage, the size of the field, the size of the zone, all of that. So this is, assume there is an optimization behind that. And then, so you have zone, the blue zone is 1, 6. The green zone is 2, 6 as well. and the red zone is 3, and it's 6. Okay, so these zones, the red dots, these are dead devices. So these are devices that were all active and then they died. So when each zone brings its numbers, it's gonna say, okay, I have, like for example, zone blue, say, I have 1, 2, 3, 4, 5. I have 5 active zones. And I have degree of connectivity of maybe 2, 3, 4. Green zone, I have 1, 2, 3, 4, 5. So I have more active zones. I have degree of connectivity of 1, 2, 3, 4, but I have less degree of connectivity. Zone, the red zone has the highest. 1, 2, 3, 4, 5, 6. And it has only 3 dead sensors. So its degree of connectivity is much higher or higher than the others. So the SDM will say, okay, each of your zones bid, I'm asking for an English auction. So give me the highest data or the connectivity you have. So number of devices you're connecting to. How many, what's the power level? And what's your history of reliable delivery? And based on that, it will make a selection on a zone for 1 round. And then it repeats the next round, bid again, and collect the data. And this way, we try to keep maximizing the use of the nodes until we get to as many survivors as we can and until the whole field turns red. Okay? So one of the studies that we do in the simulation is to see, after I run something like this for 2 or 3 days, for example, how many surviving nodes would come out of this and how many dead nodes. If I have, and if the outcome of this, for example, is I have many active sensors, but from a zone perspective, I have all the zones are dead, then my algorithm is not optimal because it means that I have killed the connectivity between the sensors because I've overused some of them to the point that even though I have active sensors, they're not able to talk to each other. So they are as good as dead to me because they're not able to communicate. So the idea is not necessarily to have everybody alive. The ideal thing is to have them all active and then all dead. But you're not going to get to that. So what's the optimal way to get to a balance where if you're running for 2 or 3 days, you are still able to reach all the devices as long as you can. Okay? These are some of the known algorithms that were done in that space, in the algorithm or optimization space for data collection. The first one is the one I just walked you through. So these are different comparative views. So the environment, static versus dynamic. So if the environment is dynamic in the sense mobile devices, so things are moving, things are not static, how do you react to it? Environment volatility. If the environment doesn't have infrastructure, if the environment doesn't have connectivity, how do you operate on that? Device type, wired or wireless. Device deployment. Can I deploy devices randomly or on the go? Like, for example, the example of the roach that they inserted the sensor on its back and put it in. That can become actually a way to activate the zones. Okay? So can your algorithm pick a new active zone the next time? Or another example, let's say a disaster happens and somebody's trapped and that person's phone was off or didn't function at the beginning or didn't have signal initially. But then when he did something or he moved in the trapped area where now he's getting signal. So initially he was not active. Later on he became active. Can your algorithm detect that in the next round, or it will always be this zone was dead, it's dead all the time? No. You have to be dynamically flexible to detect any changes. Okay? Data sinks. Do you work with centralized data sync, which is the point of failure, one central point of failure, or do you work with different points of failure? Okay? So, and the heat map here, green means it maps this and it can react to this successfully. Red means it cannot. Yellow means it's okay, but it's not optimal. Okay? So that's kind of a heat map comparison on that. These are the values of the case study. So I ran 10 primary set experiments. So the different experiments about the disaster situation, simulating it, 10 different experiments, 60 unique experiments. So 10 sets, which is the parameters, 60 unique experiments, and 360 different data graphs or data results that we pulled out to study how the algorithm behaved and how it can be improved. Okay? This is the actual simulation run. So this is kind of a snapshot during the simulation run. So the sensors here, you can see they are moving. So this green and yellow halls, they are basically the range. And red, these are dead sensors. Pink, they are close to being dead. Green is still high power and high reliability. Yellow, they are in between. And the blue, dark blue, these are the SDM. These are the responders, the emergency responder, the people trying to help. So they are walking. This one is walking inside the field. This one is at the edge. So you have to basically make sure you follow the responder. So again, remember the mobility and the dynamic nature of the algorithm has to detect if you're able to move and you still can connect to the field. So I used the Dutch auction or the English Dutch auctions, and I compared them to two kind of famous or known algorithms. This one is called the maximum path traversal. This is you heard about the greedy algorithms. So greedy algorithms, they don't care about balance. You tell it, okay, I want maximum data. It maximizes data at the expense of everything. Power consumption, processing, it doesn't matter. I'm gonna be greedy in one value, which is getting the data to you. Okay? So that's considered the greedy side of getting high reliability of data. Okay? This one is the tree-path traversal. It creates a tree map of the field, and it traverses the nodes by route. So it goes, okay, this is my closest, so this is my next node to the next until you get to the leaf. So there is binary trees, there is traversal trees, there is different types. Okay? So these are known algorithms. This is my own algorithm. One thing, and this was a snapshot towards the middle. I think it was the middle, but you can see actually towards the end. This was towards the end. One note here is that the number of dead sensors in the English and the Dutch was less. Even though I don't have a whole lot of green, but I have much fewer red compared to the tree, and of course compared to the maximum path, which means I am able to maintain active zones longer than the greedy algorithms. I'm not giving you the best results, but I'm giving you the best balanced results. And the reason why is here, I am not balancing for the best data. I am balancing for power conservation. I don't want to consume battery. So for example, if I used one node too many times and I see its battery went below, for example, 50%, I'm going to start to go easy in that node, and I'm going to go to somebody else. Unless I have to. If I find a different path, I can skip that node for a few rounds and then come back to it. You see? So it tries to distribute the behavior of how I collect the data so I can survive the longest. So at the end of the run, I have more active zones in the algorithms that I put in, the heuristic ones, versus the greedy algorithms that are out there. Okay? This is some of the results. Again, it's a little bit, I'll explain it quickly, but this is field energy. So this is the average power consumption. So if you remember that previous image, these are the Dutch and English. These are the auction theory algorithms. These are the greedy ones. We are able to maintain a balanced power, even though it's going to go to a dead at some point. But you can see the curve resisted the sharp drop compared to the greedy ones, which went steady. So and this is, by the way, this is load. So the first one is you're getting a transmission every 270 seconds. This one, you're getting a transmission 210 all the way until every 30 seconds, which is very fast. So even with very aggressive transmissions, people are panicking and pressing the button. I'm still able to survive much better than the greedy ones. Number of dead sensors. How many dead sensors did you have at the end? Again, the auction ones were able to sustain a balance on the dead sensors. And again, we started with a hazardous environment. So one of the auction, this is the random, sorry. The number of dead sensors went up significantly on the random and the greedy ones, but the auction ones, the number of dead sensors was low, And then it went high when we started having very frequent response. This is one of the, I think it's the most realistic view of this. So this is an environment. The hazardous factor here is how volatile the environment. So if, for example, if the building that collapsed is still shifting, or if there's still more earthquakes or tremors are still happening after the earthquake. So how is your sensor, how is your algorithm dealing with that? So you can see it's going up and down because it's stable, not stable, stable, not stable, but it's still keeping a steady stream, almost flat, compared to the greedy ones, which almost went dead right away. So we lost connectivity just like that. They were able to sustain and resist the changes on that, on the number of the hazards of the environment. Okay, so before I start on this, any questions, feedback? Okay, I know I bored you to death. I know I did. I was telling myself I'm not going to do it, but I couldn't resist. Okay, this is fun. This is a little bit fun. So I showed you the theory. Let's talk about where do we practice or where we can apply this kind of concept, okay? I'll tell you something that happened, this one. This has actually happened in the US, in California, a few years ago. There was an earthquake that hit San Francisco, and the Red Cross was trying to mobilize its help. They used for the first time an algorithm that used social media, and it was brilliant. And it used something similar to what I just showed you. What they did is that they looked at social media to see who is asking about somebody in a specific address. So for example, let's say I have a relative who was in that location that I lost touch with because there is no phone connection, whatever. So I'm asking about my friend in this address, okay? If 10 other people asked about somebody else in that area, then that area gets a number. So this red area here has 22 requests inquiring about the people, which means there is a chance of 22 people trapped or survival in that area. Versus, for example, here we have 2 only. Okay? So by creating this kind of map, which is, again, remember the zones, the radius, all of that, they created an auction model that now you can use auction theory to bid on which zone to go to first, or which area to go and navigate and try to help more. The higher the number, if I'm going English auction, then I'm going the highest number, I'm going to go for 4 to help first. If I'm going Dutch, then I'm saying, okay, you know what? Anything below 7, I'm not going to touch. Anything better than 7, I'm going to go after. Okay? So this is one way of this being applied. Another example where auction theory is actually can be very helpful, or at least can give you, is the blockchain algorithm. A lot of blockchain, if you know, it's basically self-contained algorithm. Every node is self-processing. So there is no centralization blockchain. It's completely decentralized. Each node has its own processing, decision-making, and autonomy about how to behave. If you make each blockchain an auctioneer, and every node connected or every auctioneer connected to it is a bidder, then this is how you can do data maximization or data optimization against multiple values. So the good thing about the auction theory, you can replace my field coverage and my power and my data processing with something else. You can make the values that you go after money. You can make the values that you go after is data quality. You can make the values go after number of people connected to that node. So you can make the auction commodities different based on what you need. But this is a high area where you can consume something like auction theory in. And then social media as well, decentralized commercial advertisement. So today the advertisement model is collect data from different sources, put it in a centralized data center that's owned by Google, owned by Apple, by whoever, and then they start basically creating these targeted advertisements for you. The future is going to be to decentralize all of this. And every company or every commodity owned, you become a commodity, and there will be people bidding on you. So people who are making more than X dollar, they are commodity for high-end players. Like, for example, the Android phones, like the low ends, they're not going to go after, for example, customers who are making $200,000, for example. Apple will go after these people because they are the ones who will be spending that money. So how do you decentralize this kind of campaigns and make it self-contained by different nodes or different valuation? So these are kind of future trends that you might consider for a way to expand this kind of concept of optimization or auction theory into future technology trends. And then the last thing is the challenges. What I just shared with you is the idea and the concept, and it has application. We actually applied it in some of the activities that we're doing. Some of it, even in my professional implementation, I implemented auction theory to optimize some of these data collection. However, when you talk about now the global world, we have challenges that, I don't know why it went up, but so privacy concerns is number one. So again, to be able to do what I just mentioned, there has to be a balance between consenting to what data you share and what is considered now, I am basically going too much into your privacy information. Okay? So that's one definitely big area of challenge. One of the examples I gave to the students a couple of days ago is that when we were talking about future trends in IT and technology, so I told them, look, the problem that we have right now is more around the laws more than the technology. In the sense, if an autonomous car hits somebody, who's to blame? The car is self-driving. There is no driver. So who are we blaming? Who is the insurance going to go after? Is it the company that made the car? Is it the company that made the algorithm? Is it the company that installed or manufactured or put together the car? Is it the passenger sitting on the passenger side? Who's to blame? So the technology is moving fast. The laws to govern this evolution is still AI. For example, the whole ChatGPT and whether it's ethical to use ChatGPT to do your homework or to use ChatGPT to help you with your work, where is the line? I mean, if I am telling ChatGPT the idea, and it's my idea, and ChatGPT gave me a way to do it, why is this, for example, plagiarism? It is my idea. ChatGPT didn't tell me what to do. I told it what to do. So where is the line here? These are things that's going to become very interesting to navigate through. And I predict that the biggest challenge we're going to be dealing with in the next foreseeable future is, as technology moves very fast, is the ethics side of that technology. Privacy, ethics use, how to govern it. And that's the way to think about it. Technology is never going to replace, I don't believe technology is going to replace jobs. It's going to replace people who don't want to evolve in how to use the technology. And the example I gave a lot of people is 20 years ago when Microsoft Office came out, and again, I came from the generation that we had to use LaTeX. I don't think any of you heard of LaTeX, but LaTeX was a script language. It's a script programming language that we had to use for our PhD or our thesis to format our paper. And we had to, the font size, all this, it was a script. It was not something that you change the button menu. So that was my time in my master's and some of my PhD. But then when Word and PowerPoint and Excel came in, did it replace people's job? No, it gave people a way to use technology. So basically people had to train on the technology and be users of the technology. So remember that, because your guys are going to be in the market very soon, and you're going to have to think about, you're going to be either a user of a technology, so you're going to be the one who configure a solution like Salesforce, like SAP and all of this. They have built the product, the ERP, the security tools, whatever. You're going to configure it. You're not going to build it. And there will be people who are going to work on the product side. They will be developing these solutions. So an AI is going to be on both sides. You just have to be the one, AI, quantum computing, again, social media. And so there are different ways to navigate that space. So I hope with what I shared with you today, again, it was a little bit more technical on one specific area, but I wanted to give you something about when we say smart cities, it is smart to the point of how we use the data. And it can be so dumb, even though you have all the the technology in it, but we don't know how to use the data. And to use the data, you have to think about how to optimize the use of the data and how to manage or manipulate or mine the data in the right way, in the ethical right way. And then one thing that's missing big time, and I would open this question to anybody, is to consider how to utilize the smart generation we are in into helping people in crisis. Because in crisis, there is no rules or boundaries that are set. You have to be working in an ad hoc environment. How can your algorithm, your work, your application, your solution be as smart or as resilient to ad hoc situations as it can? Because it eventually could save somebody's life. Okay? With that, I want to thank you. Appreciate the time. I know I taken longer than I should have done, but it's been a pleasure, and I really enjoyed your attention. Some of you dozed off, and I forgive you for that. I will not complain or call you out, but again, feel free to, if you want to reach me. My LinkedIn is there. I have in the slides. I have in the slides my email at the end. So LinkedIn, email. Just let me know if you want to have any questions, if you need any help with your work, any feedback. More than happy. I love to do that. It's passion, like I said. It's more than anything else. And I love working with students. So I hope that helped everybody. And thank you for your time, and hope to see you soon. Thank you. Any questions? Feedback?
So, Professor, first would like to thank you very much for the presentation, for all the knowledge that you shared with us. I personally, I am a civil engineer, so I don't.
By the way, the professor that helped me with optimization theory, actually, he's my mentor in optimization theory, is a civil engineer.
Really?
He's actually the head of the civil engineering department at SMU.
Wow.
And he's the one who taught me queuing theory, optimization theory, because this whole thing came from traffic management. This idea of optimization, queuing theory, and so on came from traffic management. So I took a concept that he's using in civil engineering, and I applied it into data management. So you're in the same space, so we're good.
That's good to know. But you explained so well that I could understand what you were talking about, even if I don't know coding or. It was fantastic. Thank you very much.
I appreciate it.
And I have just one question.
Sure.
How, as we are civil engineers, like infrastructure, how could we help to maintain some resilience in this situation? Is there a challenge for how could we help to you get the data, I don't know, any other, do you think there is a...
So let me tell you two things. And this is something I told I have 3 boys, 20 years old. He's going to, or shooting to become a dentist. My second one is business. And my youngest is still in high school, but doesn't want to even do technology. So I did a good job scaring them from technology. So none of them wants to be in technology. But one thing I told them, and this probably will give you part of your answer, or ask you a question. I told them there is not going to be a field out there, no matter what discipline you're going to be in, that will not work with technology. That time that you can work on paper because you're a civil engineer or you're a mechanical engineer or whatever, that time has gone. Even if you're a lawyer, that time has gone. Your time now is going to be, you're going to find a way to use your discipline, work it with technology. Okay? So, to your point, civil engineer is the core essence of how we design smart cities. Because smart cities without the right traffic, the right optimization of roads, infrastructure, I mean, what's good is it if the ambulance cannot make it to the site? So it's done. So I think the area where you can fuse you can get the fusion of your background with this is how can you look at the data that we are collecting, because I am a technician that's going to get you the data. You're the expert in the civil engineering, in the city planning, that should take the data and say, you know what? We cannot design roads to be all facing this route or this direction, or buildings that higher than 4 floors cannot go with roads that are smaller than this, because in the data we collect, if the building collapses front or back, then the simulation which we can create for you technology will cause this kind of disaster and will not have a high rate of survivor, or the emergency responders cannot come in. So there is already a huge field in that of how to optimize smart cities, the true smart cities, to really be built in a way that it's, if a disaster happens, there will be a way to work around it. So I think the short answer to your point is you have to figure out how to utilize the data, how to utilize the new evolution of AI and the new brain power that we are getting on top of our brains to help us assess computational questions that we, like the what if scenarios that you have to think about. Now you have a press of a button, you put the question, and it will give you all the different probabilities and statistics and the issues. So you can now design better about how your civil engineering or city plan should look like. Does that help?
Very, a
you.
lot, a lot. Thank you very much.
Alisson, eu acho que uma área, an important area that I see in the US also being worked is the resilience of the cities, no? And how we as engineers can make them more resilient. We have here a problem with rain, high level of rain, and like at least 5 or 6 days a year, we stop the city. No one goes to school, to university, to work. So imagine how much, and the people who live, like we have about 70 to 80% of our population living in not formal housing, I would say. That's a big amount of people, like in favelas, in close to the hills. And when there is a rain and everything stops, desculpa, so like we need a lot to strengthen our infrastructure so it works when this crisis happens. And I think at the same time we know that we have to also be collecting data and sending it in a reliable manner so the people who are actually working on it can make use of the data, and the population too, actually, no?
And by the way, one of the biggest challenges you're going to see, especially in countries and towns like, again, in Brazil or even Egypt, we have these favela kind of cities that they happen because randomly some people got into an area, the government didn't fund, so they build their own houses and they become now an infrastructure ecosystem on their own. And these are the people who struggle the most and suffer the most. If one fire happens in one, it catches up in all of them. So you have to start thinking about, we can't say, okay, these are the leftover, but we have the nice places, the downtowns, whatever to care for. There has to be included in that ecosystem, and how you convince them that there is a better way. So that's part of where the civil engineer with law, with social consciousness, with technology can all come together to create a new model or a way to migrate that community into something more sustainable. Okay, and it has to be low cost as well. So again, how do you use that technology to help you simulate what kind of reusable resources, low cost infrastructure? Now with 3D printing, they're now building homes in, I don't know if you've seen that, there is a company in the US that's already actually working with the Red Cross. Rather than creating tents for refugees in disaster areas, they're actually bringing like Lego houses. The house comes in a box and it's pre-made and it's all 3D printed. You should look. It's in. Forgot the episode. I'll find it, but look, Google it up. It's basically a ready-made 3D house, a small house, but it's shipped in a box, and they basically bring the walls, put the. It's not even a pins. It's like a long pillar that you put it in, and it's flat, and it's much better than a tent. So this kind of model is gonna. This is where, again, you can think of a quick way to solve their problems with something that's sustainable.
Congratulations. It's a very important theme. I'm so suspected. In Brazil, we have very realities. There are, how can I say, rich countries like São Paulo, Rio, Curitiba, and 90% of the countries are very poor.
Yeah.
And the smart cities is like Cabrobó na palma da mão.
Yep.
We have problems of light and rain, but yes.
Yeah.
Yes, and I have a big problem. There is a lack of data in the government databases. And how can I work with this? Because it's so difficult. It's not real time. Nothing is real time. And it has a big lack of data.
So I think the short answer to this is that our phones, what I mentioned at the beginning, that what we're calling smart cities definition will have to evolve. The nice, shiny, smart cities like the Tokyo, the New York City, and not even all New York City, just the Manhattan, the busy areas, the Wall Street areas. These are the areas that are truly smart, built for sustainable energy, all of that. But we have to expand the definition to become now looking at the population in that city or town and the amount of penetration of smart devices on these towns. 5 or 10 years ago, not everybody had a smartphone. They had cell phones, but not smartphones. So the cell phone, we're not getting a whole lot of data. Just a hello, goodbye, text message, and that's it. There is not much data about it. But now with the evolution of phone and the cheap phones that are out, smartphones, now you have probably 90, even 100+% of people handling smartphones. It doesn't matter if even your social status. You could be poor as heck, but you still have a smartphone. And I see it in Egypt, because Egypt has exactly what you're talking about. The population, 100 million, about 3 to 5 million are the elite. Middle class is shrinking, and there is a significant chunk of the population who is dealing with poverty. But for everybody's surprise, even the people who are considered below the poverty line, they have smartphones. So the point is, the definition of being smart about the people we have has to start looking at the data we have from you, because we're collecting data from each other through our navigation, through our social media, through all of that. So we can use that to, again, right now it's used the wrong way. So I don't like the way it's being used right now, especially the way the political aspect of it. But if I'm in an ideal situation, there is enough data that we can gather from this that can tell us which areas are higher density than other areas where we should look at and try to help with the civil engineers how to make the spacing between buildings, for example, the infrastructure, maybe put a fire station closer to them. This kind of data is there. It's just that, again, I don't want to get politics, but there is a lack of interest from the governments, or at least in some governments, to help that sector. They're interested to help the people with the money because they are the ones who are going to pay. I think that there is some kind of a social aspect. I don't think it's a technical problem per se. It's a more of a political problem. But the technology there is an answer for. I think if the political will is there, I think there is a way to answer or to have an improved lifestyle, even for people who are not doing well, that they can survive all of this. I mean, look at the homeless. It's a pandemic across many countries, and I don't understand, with the amount of money that's out there and the technology we have, we can create shelters for these people. I mean, there is plenty of space that's not being utilized. Again, do we want to do that? Is there a will to do that? That's the question. I think if this presentation
I pass the
is
word
probably going to get me
to
banned from Egypt, so I'm going to try to be careful.
Dr. Hazem. This is Professor Ruben. He's our international relations coordinator now at Poly. So he has a question.
Thank you for coming to Poli in the name of the university and this wonderful presentation. I
Thank
think you inspired a lot of thoughts here.
Thank you.
That's a good way to see how we can deal with smart cities and where it touches every area of the engineering, not only civil but electrical, mechanical, everything. Um, one thing that people don't really think about when they are creating new technologies, and I think this is concerning, is the lack of worries about privacy.
Yeah.
And I am really annoyed by this concept because, for example, I think I am the only one in the university that does not have WhatsApp. I don't use it. Yeah, and in other things as well. For example, I do have an Instagram that's from the same buyer, the so-called Mark Zuckerberg, but I don't have my contacts in the Instagram, so they can't profile the connections I have. If people ask to follow me in Instagram, I don't follow. I just follow professional photographers. That's it. That I don't know. But when you say when you keep installing IoT, Internet of Things in homes, in cars, I remember in the beginning of the presentation, you said, "This is you. This is you."
Yeah.
They track everything, and you know, governments aren't always that good for people. Huh? There are problems that need to be addressed, and if you keep enslaving ourselves to governments and adding technology that help them track you and help them, even autonomous cars. Autonomous car. What's the big, the grateful thing you do when you buy a car, when you are a new a young person, you buy it for the freedom to drive away. So that's the advertisement. But now autonomous car, you sit in it and you go where the government says you should go, and don't go anywhere else. So uh, when you think about everything, uh, well, maybe where you are in the world. For example, if you are in the central or in Egypt or in the Orient, maybe there are needs for the people who don't have houses. They need things that help. They need water. That's a way to look to smart things. We can implement and try to comfort those people. But when you look, for example, the mayor of New York last year set a rule to uh, put what's the spikes in the banks in the streets to avoid people to sleep in the streets.
Yeah.
So it's the opposite of the smart city. It's the dumb city. I don't know what's that. So it really depends where you are looking in the world.
Yeah.
Huh? But please, your talks in privacy. Thank you.
I'm traveling tomorrow, so I just want to get out and be able to enter the US. That's what I'm hoping for. If I go too much into this, I think I'm not gonna go anywhere, and you're gonna have to find me spots here in this school. No. Look, you're spot on everything you said. Okay, uh, I am skeptical, but I'm not paranoid. Okay, there is a big difference. Paranoid means that I mean, I know they're gonna come after me. They're gonna do this and this. But to your point, depends on the location. So if I'm in a certain country, I don't want to say the name, but if I'm in a certain country, I have another phone, not this one, that has nothing. Okay, just the phone. That's the phone I use over there. Okay, because not even they are looking in my. I mean, they wait for the data to be gathered. They could stop you in any police stop and ask you to open your phone and show us your political opinions. Okay, so it can get that bad. Okay, so they're not even waiting for you to share your information. They will go and find your information from you. Okay, so unfortunately, there is this kind of bad out there in the world. However, there is a lot of goodness on sharing some level of the data. Okay, I think, I don't know if you were in the beginning of the talk, but one thing I mentioned is that when I asked the question about what's a smart city, we didn't get a single definition, different ideas. Okay, so the concept of data and sharing data, there is value to it if it's, first of all, a certain level, and second of all, it doesn't penetrate or become too personal. So, for example, the example of Apple, there is, if you have an iPhone, there is a health card that's in the phone for you, and actually you can pull it, and you can see, you can set up your blood, allergies, history, surgeries. This information will save. I mean, it's actually been reported it saved people's life. People got into accidents. They need blood transfusion immediately. There is no time to go and test their blood type and figure out, or wait to call somebody or relative to ask them what's your blood type. They were able immediately, because the phone automatically detects the danger. The phone immediately doesn't unlock, but it changes its front page to be your health screen. So they don't have even to go find the information. You can look at it right away, determine what's your blood type, your history, and they could save it. And there are people that their life was saved because of that. Location tracking in the right way saved many people's life. I mean, all the new cars right now, I don't know if you have it here in Brazil, but in the US, most of the cars, if you're in an accident, the car itself, even if you don't have your phone, automatically dials 911. And somebody talks to you, are you okay? Are you safe? Do you need help? And I was personally involved in an accident like this, where the car in the middle of this, and I find somebody talking to me and say, are you okay? And I was like, I was dizzy and I couldn't. And then, yes, I'm okay. And do you need an ambulance? I don't know. I think so. So these things are the good side of the technology. So that's why I'm saying I'm skeptical, but I'm not paranoid, because I think we need that. Okay. Now, talking about a city and talking about how we use data in a city, there is a good example, and there are many bad examples. But a good example, when the pandemic happened, countries like China especially, they had the technology before the pandemic where they do facial recognition on the street. So they know who you are, where you've been, from their surveillance system that they have. And they're doing it to make everything smart for the people. So people get the benefit that they go to the bank, they don't even have to, you don't have to show an ID. They know who you are, they know everything, because it tracks your surveillance. When the pandemic happened and they were trying to control the spread of the virus, they had to, when people were asked to quarantine, they could tell if you left your house or not. So they were able to control some of that through technology. Again, it's a good way of using it, but it's still, if I'm a person, why are you even tracking me where I'm going? And I mean, what is my freedom? Okay. So like I said, if there is a will to use the data in the right context, the data is there. The problem is this area is too political these days, that it is not allowed to find its right ethical use of the data. And I think, again, there were attempts in the past to create kind of a global governing body for data use. It always became like more of a recommendation. There is no mandate. There is no power behind it. There is nothing like a UN-like where it can enforce mandates. And countries will always have its own political views about how to use the data. So until then, I think the best way is to think about the critical areas of data where it's health, it's risk, maybe some of the entertainment. Because, for example, when I look at my Netflix, for example, I see recommendations of movies I like. I don't want to keep navigating 10 different or 100 different movies to find the interest that I like. Sometimes this is not a bad thing. I mean, some people don't like it, some people like it, but it makes my life more convenience. If I give the example about the Google and all of this, where we're thinking of this as luxury for you and me, because thank God we are healthy. I don't have a problem walking, I don't have a problem seeing, I don't have a problem hearing. But I know people who have hearing impairment, people who have blindness, people who have MS, multiple sclerosis, who can't move. And this kind of technology is a lifesaver. It brought them back to life. I mean, imagine somebody paralyzed from the neck down. And I know a guy in Dallas who dealing with that. When that technology became part of his life, where he can talk to Google, show me this, do this. I can't tell you the excitement he has to wake up every day now. So I agree with you. There is a lot of skepticism about the data use, but you have to always keep the good side of it so we don't lose everything while we're trying to prevent everything. Does that help? And I try to be as careful as I can because this is recorded, so.
There is a way to implement a smart city in a way that I guarantee that the data keeps anonymous, or we have to, believe that we are safe with our data.
I don't look. Yes, anonymous use of data is there and it's available. Apple, for example, your phone cannot be unlocked by anybody. Even Apple cannot unlock your phone. But hear me out. Okay. But the idea of getting the best benefit of a smart city, the most benefit, without knowing who you are and make it anonymous, yes, you will get some, but you're not going to get everything. So what I'm saying, and it goes back to the same point, there is a balance and there is a sacrifice. You're going to have to sacrifice if you want to get the ultimate convenience and the ultimate, whatever we call it, protection or safety, whatever, it has to be personalized. Okay? If you want to keep it at more of a convenience level, but I don't want to share, then it will give you some of that smart city concept, but not all. So, like I said, until we find that utopia where we are ruled by ethical governments that they have no interest but the people, this is going to always be a preference. And it's the adoption of a true smart city other than the infrastructure, which is really the building has fire hydrants, the building can sense this. If the heat goes up, that your thermostat will detect this, and you keep yourself anonymous, yeah, that will work. But if we get into that specialized area where it's healthcare, or if there's a problem, or I'm trying to control, for example, a pandemic or whatever, it's going to get to a little bit of a personal level, and that's where we get into that debate. So there is definitely, and I repeat this, and a student on that federal school is doing law or interested to go in law, and I told him one of the big areas, because he was talking about criminal law and so on. I said, look, there is many lawyers in that space. If you're talking about the future, the legal system in the future will be heavily influencing the space of data management and data use and what's right and what's wrong. Because right now, there is no book, there is no law book that says exactly this is right and this is wrong. It's more either cases that happened before or a new case, and they bring people to testify, and then how they use the data, and that becomes a new law. So these are the areas I think will be something that probably your generation has to deal with more than probably me or my generation. And also you will probably have to set the trend and the ethics of how to use it. Does that help? Yeah. Any other questions? So you're the champions. You're the one who survived until the last minute. So
thank you so much, Dr. Morse. It's very interesting. And I think we talked about technology, cities, all these things. But remember who's behind all that. It's people. I always say, eu não posso construir uma sociedade de ouro com pessoas de chumbo, né? We don't create a society of gold with lead individuals. We need golden individuals. And a educação de vocês, education is so important in this process. If we have ethical people, then they'll have ethics to use this data in the best for society. So I think what we do here might not be so, like top level, but if we have people that are ethical and we can educate you, so you can use your abilities to know that the best for society is the best for you too. I always say inclusion, you're not doing any favor to anybody. You're choosing the best solution at the end. When you have diversity and have everybody, contributing, consulting together, you get the best solution. That's why it's the best. It's not because you're helping people. They are helping you and helping everyone to get the best solution. So I think although we talk about technology, I think we don't talk enough about the need of education in all sense of this new generation. And I have a lot of hope that in one generation, if we really work on you, you're going to change this reality. And I won't worry about who uses my data. I always say my life is an open book. Use whatever you want. Because I think if it's for the best of everyone, then it's, I can lose a little bit of my freedom for that. So anyways, thank you so much, Dr. Morth. Do you want to say anything else, Lugia, please?
Can I just say something?
Yeah,
Can I
is
just
always.
say something real
Oh,
quick
go ahead.
to the team? So thank you for hosting me. It's been a pleasure. I mean, by the way, I learn from you as much as you learn from me. Even though, I mean, the question you asked me, the reaction to my slides, the feedback, it's self-learning for me as well. So I want to thank you about that. That's one. Two, you are in a, and I'll tell you this honestly, I've been here for 4 days. Okay, you have a great opportunity. Yes, maybe the facilities are not the most elegant facilities, but your professors, the way I've interacted with them and the way I see they care about you, you are definitely in a very healthy environment for you to make something of yourself. And it's a privilege you're not going to see in many places. Okay, so this is one. Two, the topics that your professor asked me, and I've seen, and I looked up your school, and by the way, I've been navigating, trying to find out what you guys do. You guys are doing a lot of cutting edge technologies. So you're not left out. So I would disagree a little bit with Professor Emilia on that front. You are working on stuff that's really ahead of the game here and in the other school, the Federali school. So don't underestimate what you have, the power you have. And the third point is, don't trap yourself with, and this I tell this to also my boys, don't trap yourself with the mission, I want to get a job to make money. Find the passion that you want to do, and money will come. I tell you this from experience. I'm not telling you, I've been there and I've seen it. Don't be fooled that I will do something I don't like because it's going to give me more money or I'm going to get a better salary. Do something you like and it will bring you money. The best thing you can do for yourself and for the people around you and for your community is to wake up every day really enjoying what you do and you have a passion to solve a problem. And then the last thing I want to leave you with, think of a problem. I mean, you see a lot of things and you ask me great questions. Think of problems that you think you want to solve and don't underestimate anything. Small problems, big problems, you guys will solve it. It's just that we'll need time, passion, and commitment. And from what I've seen, I mean, especially the people who stayed here until this late, you guys definitely will do very well. So please follow your passion as much as you can, but be smart about it. And the point I made about my career and how I pivoted, my passion was football, then became academia, and then became professional, and then back academia. It's okay. This is not a failure. And don't be fooled by what you see in social media, whatever, that somebody is making this millions or whatever. This is not success. This is a fake kind of illusion that they try to sell to you, that this is how it should be. It's not. The success is that when you impact people's life, when you are doing well, when your family is doing well with you, and that's what you're going to feel happy about. It went a little bit philosophical, but I want to leave you with that. Thank you very much, and hope to see you soon.
Would like to express our gratitude with our famous delicacy from our city. The name is Bolo de Rolo. This is raw cake. And your last talk in these moments, the last minutes, for me were the best, because we have always to say to our students, to our children, this kind of things. Thank you very much. Thank you, Emilia, thank you.